Of all the breathtaking natural spectacles that occur on the numerous celestial bodies of our solar system, those phenomena that repeatedly rage on Saturn's moon Titan are by far among the most fascinating. Above all, one groundbreaking conjecture about the iconic ringed planet's constant companion stands out: the existence of a subsurface sea of liquid water. In the following video, you'll find out which indications point to the existence of a subglacial ocean on Titan and which amazing forces of nature still prevail on Saturn's satellite. As always, we hope you enjoy this exciting topic. Do you want to learn more about groundbreaking discoveries, great mysteries, and amazing phenomena in space on a regular basis? Then subscribe to our channel and activate notifications to stay up to date. Feel free to give our videos a thumbs up to show us the support for our content. Titan. Dimensions, characteristics, features. Gigantic lakes and rivers of liquid methane and ethane, imposing cryovolcanoes, an impenetrable cloud cover of nitrogen. Titan immediately fascinates us with its natural composition. With a diameter of around 3,200 miles, this satellite is not only Saturn's largest galactic companion, but also the second largest satellite in our planetary system overall. By comparison, the planet Mercury has a diameter of just 3,032 miles. Titan differs from the other moons of the solar system not only because of its dimensions and material composition, but also because it's the only known satellite in our galactic neighborhood with a dense atmosphere. Such a thick gas shell can otherwise only be observed on planets. The atmospheres of the other moons are sometimes composed only of very thin layers. Specifically, Titan's surrounding protective shell is even denser and thicker than Earth's atmosphere. This dense blanket, consisting mainly of nitrogen, extends up to 300 miles across the surface of the moon. In terms of its average surface temperatures, the icy moon is again characterized by a bone-chilling cold. On average, the thermometer on Titan does not rise above -310 degrees Fahrenheit. These frosty conditions are due to the moon's position in relation to the sun. As is the case with Saturn, the ringed planet and its companions are separated by a distance of more than 870 million miles from the central host star of our planetary system. By comparison, the distance between the Sun and Earth is about 90 million miles, which means that our home planet is regularly reached by sufficient warming rays from the Sun. The bitterly cold conditions on Titan result in the surface of the imposing moon being covered by an incomparably thick layer of frozen water ice particles and methane hydrate, but also make another incomparable condition possible: the existence of methane lakes and rivers in permanently liquid form. Unique methane waters. Although Saturn's moon is exceedingly different from our home planet in terms of its chemical composition, the two celestial bodies nonetheless share striking similarities in their landscape formations. In spite of all its methane waters and cryovolcanoes, Titan is the object in our planetary system that has the most Earth-like surface. It was the groundbreaking findings of the Cassini-Huygens mission that finally gave us a deeper insight into the surface world of the icy moon. Thus, at the beginning of 2005, the Huygens space probe landed on the outer surface of Saturn's satellite, the first man-made object to do so. Subsequently, the technical equipment succeeded in collecting important data over a period of about 72 minutes, which was then transmitted to the earthly scientists. Ultimately, the highly complex measuring instruments of the unmanned spacecraft froze due to the prevailing temperature conditions, so Huygens was forced to call an end to its service after that period. The information gathered by Huygens was deepened and expanded upon by the observations made by Cassini in the following years, at a greater distance from Titan. Thanks to the successful space mission of NASA and ESA, which started in 1997 and was not scheduled to end until September 15, 2017, we now know that Titan's surface practically resembles a galactic patchwork. What appear to us in the corresponding images as dark formations against a bright background are in fact countless accumulations of liquid methane and ethane. These unique chemical compounds are present in the most fascinating and diverse forms. The surface of Titan is not only adorned by gigantic methane oceans, but also by countless smaller lakes and rivers. As already briefly mentioned, the corresponding substances on Titan can only assume a permanently liquid aggregate state because the celestial body has always been characterized by a frosty cold. According to current conjectures, the liquid on Titan plays about the same role as the water on our home planet. While the larger methane accumulations on Titan are fed by subterranean inflows, the smaller counterparts draw their chemical supply mainly from the methane rain that regularly falls from the atmosphere onto the lunar surface. Just like the water on Earth, the methane on Titan is subject to a constant cycle, as a result of which the chemical compounds evaporate, rise into the atmosphere, and then rain down again on the outside of the moon. The gigantic subterranean ocean. The successful Cassini-Huygens mission not only helped scientists to better understand the surface structures of Titan, but also to gain an authentic impression of the nature of the moon's interior. Radar measurements taken by the Cassini spacecraft suggested the incredible conclusion that there is a vast ocean of liquid water beneath the massive, approximately 50-mile thick ice crust on the moon's outer surface. In order to investigate this groundbreaking hypothesis in more detail, experts used the model that had already helped them study the subglacial waters on Jupiter's moon Europa. In the process, the experts realized that it was probably the effects of tidal drift and the associated heat generation that caused the lower layers of the ice surface to melt and form a gigantic subterranean sea. But how is it possible that water on Titan can exist in a permanently liquid form, while the average surface temperature on Saturn's moon is negative 310 degrees Fahrenheit? The answer can be found in Titan's water itself, more precisely in a certain chemical substance contained therein and its effects. According to research, the subglacial ocean on Titan most likely consists of about 10% ammonia. This chemical compound of hydrogen and nitrogen acts as a kind of natural antifreeze on the satellite. In fact, ammonia naturally has the property of significantly lowering the freezing point of water. This makes it possible for the subterranean ocean on Titan to exist in a liquid state of aggregation despite its own temperature of negative 4 degrees Fahrenheit. This is also due to the enormously high pressure that is generated in Titan. The high pressure, which prevails in the deeper areas of the moon, favors this circumstance. The presence of the subglacial water is directly connected with some effects on the surface of Titan. Conversely, the existence of the hidden sea means that the overlying ice crust must be much more mobile than on comparable celestial bodies. This circumstance could explain the different tectonic formations on the Saturn satellite, as well as the pronounced cryovolcanism. In contrast to the volcanoes on the Earth, cryovolcanic eruptions do not eject lava and ash, but ammonia and ice into the environment. The subterranean water could again play a direct role in these impressive spectacles and have an influence similar to the magma from the Earth's mantle in our terrestrial volcanic eruptions. Further data collected by Cassini also revealed that the subglacial sea on Titan must be incomparably salty. The salt content of the water is supposed to correspond approximately to that of the Dead Sea, in other words, approximately 30%. Is life on Titan possible? As is well known, the presence of water in permanently liquid form entails a possibility not to be taken lightly. It is considered the basis for the emergence of life. Does this mean then that some life forms may have already evolved in the subterranean Titan ocean? In fact, the largest of all Saturn's moons has been considered a promising candidate for quite some time when it comes to the question of the existence of extraterrestrial life. However, the hypothetical living beings would have to cope with the most adverse conditions imaginable. In addition to the freezing temperatures, the constant methane rain, and the dense nitrogen atmosphere, this also includes the incomparably high salt content of the subterranean sea. The aptly named Dead Sea on our planet, which is considered one of the most hostile areas on the planet, has a salt content similar to that of the Titanian Ocean. However, even if the body of water between Jordan, Israel, and the West Bank hosts no higher life forms, this does not in fact mean that the Dead Sea is really completely dead. Indeed, tiny microorganisms exist there that have successfully adapted to the adverse conditions. However, a devastating circumstance could soon put an abrupt end to potential life forms in the Titan Sea. The data collected by Cassini revealed that the ice crust on the surface of the Moon varies in thickness depending on its location. From this, experts in turn deduced that the corresponding surface ice layer must be exceptionally rigid, since the differences in ice thickness would otherwise even out over time. In all likelihood, this is because the subsurface ocean on Titan has slowly begun to freeze. Therefore, it's conceivable that the subglacial waters will one day completely solidify into ice. The resulting ice age would, in turn, have devastating consequences for the organisms that may thrive in the salty ocean. We hope you've been edified and entertained by our video. What do you think about the mysterious ocean under Titan's ice crust? Write to us in the comments. Thanks for watching. Take care, and we'll see you soon.